tension. Since we have the tension, we can go to our question now. I think it will be easy for us to find this. We know the tension is 23.4. So if the tension is 23.4, we minus that Fk. We say this is equal to M. What is the mass? Please, I need you to pay attention on this one. Remember, the friction is on the horizontal block. So this one is for the 5 kg block. Are you happy with that?
Yes.
So this will be 5 times the acceleration of 2. So 5 times 2 is 10. So this tells me that this will be 23.4. Let's take the 10 this side to be negative 10 and equate this to Fk. The Fk will go to the other side to be positive. Yay! Now we have our final answer. Therefore, I can give them the answer and say, what is Fk equals to? So we can see that 23.4 is like 23 minus 10 is 13. Then we still have that 0.4. Now, newtons. Right. So it's very important. You can say newtons, also put direction left. Are you happy with that?
Yes.
Okay. Will you say, I'm sorry. Is this question easy for you?
Yeah, this one is pretty simple. I think it's the one with angles that kind of get me.
Oh, yes. Don't worry. We'll also work on that because you have to change your force into components. Please, you have to change your force into components. Okay, let's try and see what we have on the second question. The second question says, we need to calculate the coefficient of kinetic friction between block A and the surface. The coefficient kinetic friction. So now, for the fact that they need us to find the coefficient kinetic, you know what I'm going to do? First thing first, on 2.4.2, I'll write the formula for that kinetic. Okay, it's Fk. I know that the friction is equal to what? The kinetic coefficient times the normal force. So that this question is the one that will tell me what I need. Do I have normal force? No, not yet. I don't have normal force. Okay, so now, do I have Fk? Yes, we have Fk. We don't have this, and we are looking for that. Okay, so remember, normal force is a force that is perpendicular to the 3 kg block. It's on the horizontal. So this will be now Fn. And now, another force acting on that is Fg. So now, can you see that the normal force, your Fn, is the same as what? It's equal to Fg, which is equal to mg. So I can just substitute this and say Fk is equal to UK mg. It's mg, mass times the gravitation. So this one we calculated it as 13.4. I'm going to equate this to UK, the mass. This is for the 5 kg block, into 9.8. So to make UK subject of the formula, we just have to isolate that guy and divide both sides by what? Divide this side by that 5 into 9.8. Divide this into 9.8. So that it's 9.8 times 5. So that these two will cancel that. We are left with UK. I need you to use your calculator. Tell me what is UK equals to. What is the final answer for this?
0.27.
UK is 0.27. So there's no SI unit for UK, okay?
Yeah.
Okay. Right. In the meantime, I need you to think on what is the answer for this final one. Let's see if you can collect these 2 marks. Né? Is this the same? Yeah. So now tell me, work on this 2.5. Tell me what is the answer for 2.5. They say identify 1 Newton's law, action-reaction force that is acting on block B. Do you know which one is it's a force? Do you know what is action-reaction? Let's start there.
Yeah.
Okay. So which one is the force action-reaction force pair?
Would it be the string on the block?
the string on the block. Yes, I can say the string on the block. I was also thinking about the string of the block. So now, what you do is that if we can look at this, the 3 kg block, we can see that the force that the rope, which is the tension, it exerts on the box. So it will be the force that it exerts on the box. I'm just going to put a circle there. And which other force? They said force, reaction force pair. So the other force, it will be the force that the box exerts on the rope. So that point is the force reaction force pair. You understand that part, né?
Yeah.